Hi, I'm Laszlo, and today I will be showing you a real-life use of a sinusoidal function. Now, say you're going on vacation with your good friend Phil. Now, Phil, though he is brutally afraid of heights, wants to go see the London Eye, an extremely large Ferris wheel. Now, Phil has found that his limit for heights is exactly 400 feet. Now, Phil would like us to figure out at what point he will be at 400 feet and should sit down and try to relax and forget that he is more than 400 feet in the air, and at what point he can stand back up, look out the window, and enjoy the ride again. We need a few pieces of real-world data to figure out at what points Phil should sit down and stand up. I have got these here. Now, we need to know the height of the London Eye, which is 443 feet. We need to know the diameter of the London Eye, which is 394 feet. We need to know how many rotations the London Eye makes. We find that it makes one rotation every 30 minutes. One good method to figure out the points where Phil has to sit down and when Phil can stand back up is through the use of a formula. Now, we need to fill in certain variables so that this formula can be used. The first value is the A value. Now, this would be the radius of the London Eye, which we find to be 197. However, since he will be starting at the bottom, going up to the maximum, and going back down, the value must be negative, so it is an inverse cosine graph. Now, we find also that the London Eye makes one revolution in 30 minutes. So we make our h value pi over 15. So the period will then equal 30. And lastly, we must make k 246, because that is the height at which the center of the London Eye is. Now that we have all of our necessary components and variables filled out, less x and y, we can solve. We put in 400 for y, which is the feet at which Phil will be, and we solve to find that he will reach 400 feet first at 11 minutes and 47 seconds, and he will once again reach it when he should stand up at 18 minutes and 13 seconds. Another method, and my personal favorite method, is using a graph. On this graph, we put the cosine function, which models one rotation of the Ferris wheel, and we put the line y equals 400. The intersection points, where the cosine graph crosses the line at 400, are the points at which Phil will be at 400 feet and should stand up and sit down. We find that he should sit down at 11.78 minutes, same as with our formula. We find that he should stand back up at 18.22 minutes. Once again, same as our formula. The last method that we can use to find out when Phil should sit down and stand back up is a data tape. And using this, we find that at about 12 minutes, which is what 11.78, which is what we got on our graph and our formula, rounds to, he should sit down. And we find that at 18 minutes, about, he should stand back up.